The usage of photonic laser thrusters is illustrated here for ultra-precision propellant-free formation flying of spacecraft to form an out-of-plane synthetic aperture on low Earth orbit. A photonic laser thruster is an amplified laser thruster that generates thrust directly from the laser photon momentum, rather than laser heating propellant. The concept of single-bounce laser-pushed light sails that utilize the photon momentum was first developed in the 1960s, however, its conversion of laser power to thrust is highly inefficient, thus has been considered impractical. Over 50 years, there had been numerous theoretical and experimental efforts to increase the conversion efficiency by recycling photons, bouncing them repetitively between two reflective mirrors in an empty optical cavity, without success. In December 2006, Young B successfully solved this problem and demonstrated the conversion efficiency enhancement by a factor of 100 and a photon thrust of 35 micronewtons by putting the laser energizing media between the two mirrors as in typical lasers, and the photonic laser thruster was born. In August 2015, the photonic laser thruster was demonstrated to increase the conversion efficiency enhancement by a factor over 1000 and to achieve a photon thrust of 3.5 millinewtons at Yk. In addition, propelling, slowing and stopping of a small satellite, 1U CubeSat, in simulated zero gravity were demonstrated. The photonic laser thruster was initially developed for use in nanometer precision spacecraft formation, for forming ultra-large space telescopes and radars. The photonic laser thruster is currently developed for high precision and high-speed maneuver of small spacecraft, such as formation flying, orbit adjustments, drag compensation, and rendezvous and docking. The photonic laser thruster can be used for beaming thrust from a conventional heavy resource vehicle to a more expensive and lightweight mission vehicle, similar to tankers in aerial refueling. The practical usage of the photonic laser thruster for main space propulsion would require extremely high laser powers and overcoming technological challenges in achieving the laser power and fabricating the required optics. Photonic laser thrusters have a very high specific impulse, and can permit spacecraft reach much higher speeds than with conventional rockets, which are limited by the Tsiolkovsky rocket equation. If the photonic laser thruster is scalable for the use in such main space propulsion, multiple photonic laser thrusters can be used to construct a photonic railway that has been proposed as a potential permanent transport infrastructure for interplanetary or interstellar commutes, allowing the transport craft themselves to carry very little fuel.